Hey everybody. So this is the notes from Tuesday. So this is the second day when we're talking about normal calculations. So 2.2.2 notes. The beginning part is just reviewing what we did in class on Monday. So first thing we had to do was go through and label our normal distribution. This is a pretty picture. This is what would be appropriate for a test or a quiz. Excuse me. For the AP exam. This is what they would be looking for. So the mean is labeled. We have 1, 2, and 3 standard deviations on either side, as well as our label over here. We have our capital N, and then we have 80, 7.7. So our mean is 80, and our standard deviation is 7.7. If you drew that, you'd be good to go. So I'm not going to go through the steps for 2, 3, and 4 since it is from Monday's notes. If you have questions, let me know. On Canvas, the completed notes have step-by-step how to do it, so you're welcome to take a look at that answer key and kind of check yourself. But as a very short one, number 2 ended up being 16%, number 3 was 81.5%, and number 4 was 2.5%. If you notice, all 3 of those questions specifically cited percentage is what they wanted as their answer. So they didn't want a proportion, they didn't want a percentile, they wanted a percent. All right, so you need to make sure that you're paying attention to that because we do have different options for our answers. So these were all the problems that we could solve with the shortcut, with the empirical rule. Unfortunately, we can't always use the empirical rule. It only works if we happen to have it at 1, 2, or 3 standard deviations above or below. There's a lot more data values than that. So what we're looking at today is what do we do when it's not at 1, 2, or 3 standard deviations? And so there are 3 steps that we always want to do when we're completing the problems. The good news is you already know how to do the first 2 steps. So the first one is just to graph the normal distribution. So again, if it was a test, whether for me or for College Board, this would be how pretty I'd want it to be. If it's homework or it's practice, I'm less concerned. So like, for example, for number 5, it's saying what percentage of the runs will give the DeLorean a speed less than 68.45. So I have the mean here. I've labeled my diagram with 80 and 7.7, and then I've drawn in the data value that I'm looking for, and I've shaded. That's plenty to be getting on with for just work and practice problems. So it wants a speed less than 68.45. So that's why we shaded to the left, because that would be less than. Pretty straightforward. So I went through and calculated a z-score. Same as we did the week before fall break. It's the value minus the mean over the standard deviation. It's part of the reason I encourage you using that label. Besides the fact it saves you from writing a sentence down the road, it also means you have that information right there to plug into your z-score. You don't have to go back and hunt for it. So z-score was 68.45 minus 80 over 7.7. We always need our z-scores to be 2 decimal places. If you put that in your calculator, you got negative 1.5. But if you notice, I have negative 1.50. I had to add the second decimal place in. The reason being is because we now have to go to another table to look up our answer, and that answer is always to 2 decimal places. So if you don't have 2 decimal places, you need to force it, and if you have more than 2 decimal places, you need to round. So very brief tangent for those of you that have had calculus. Basically what we're getting ready to look at is a table of all the possible integrals. Somebody has gone through and calculated all of them already, so you don't have to do it by hand, which, you know what, and nobody got time for doing all of that with stats. So we just go ahead and use the table. It's given to you on your AP exam, so we're just going to practice as much as we can using that table. So that is on the second page of the reference table I gave you guys at the beginning of chapter 1. It's gray, and the front side has all the negatives for table A, and then on the right side, or on the back of that page, it has all of the positives. And it would look something like this with this picture up at the top. And this picture is College Board trying to help you out. Because what they're telling us is they're saying, inside our table, we're giving you all the possible values for the shaded area. So everything in the table is done assuming you shaded to the left. So they put that picture up there to help you remember. Now I know that says probability, and second semester we will be using this for probabilities. For right now, you could think about it as a proportion. So if you're using your own gray copy of the reference table, you may want to write proportion above probability just to remind yourself that it's the same thing. So for us, we had a we had a z-score of -1.50. So the way this works is the z-scores are across the top and down the side, and all of those decimals in the middle are all the different proportions. We just have to pick the right one. So for us, what we need to do is go down on the left side until we get to -1.5, because we had -1.50. Your reference table at that -1.50 is actually in the middle. For me, I have a slightly bigger reference table because it's easier to see on the screen. So you go to -1.5, and then across the top are all of the hundredths places. So down the side are your ones and your tenths. So the ones and then the first decimal place. And then across the top is your second decimal place. So for us, our z-score was -1.50. So we're going to go all the way down to -1.5, and then we're going to go over to the first column, because that's where -1.50 would be. If we had -1.51 as our z-score, we'd move over 1. If we had -1.52, we'd be looking at the third column. If it was -1.59, we'd be all the way over on the right. So you just have to think about what your last decimal place is and use that. So for us, what that tells us is that the proportion that is below our z-score is 0.0668. So when we come back over here from table A, we got the proportion 0.0688, which is great, but the problem didn't ask us for proportion. It asked for a percent, so we have to go ahead and convert it over. So we end up getting 6.88%. The nice thing about working these problems is you can stop and kind of do a reality check. Does this make sense? So if I look at my shaded area on my graph, yeah, that looks like about 7% of the data. That seems like it makes sense. If I had something that was like 94%, I might be like, that's way too big. But it gives you an idea. Other place you could check is with your z-scores. So our value, 68.45, is below the mean. And z-scores that are below the mean should have a negative sign out front. So that's another place where you can stop and check yourself. That z-score should be negative. I look at our calculations, it was. So we're good to go. All right, so that's one way we could do a calculation. Another situation we might see is something like number 6. So what percentage of the runs will give the DeLorean a speed greater than 85 miles per hour? All right, so I've done my short little sketch, 85, and if we're doing greater than 85, that means I've shaded to the left. I'm sorry, doing the mirror, I shaded to the right. So then we go through and calculate our z-score. 85 is bigger than our mean, so our z-score should be positive. So this checks out, and we end up getting a z-score of 0.65. So once we have our z-score, back to table A again. So I'm going to jump back over here, but now our z-score is positive. So for you all, that means you need to flip your paper over and go to the back of the side of the table you were just looking at. You need to look at the positive numbers. All right, so then we're going to go to 0.6 on the left, and then our hundredths place was 5. So we have to go across from 0.6 over to 5. So we end up getting this proportion right here, 0.7422. I'm going to hop back to our notes and write that down. So as a percent, that would be 74% of our data. If you look at that yellow shaded area, does that feel right? That's not 75% of our data. That's much smaller. Well, if you remember, I said table A only shows the stuff to the left. So what that means is this is 74.22%. So we have to figure out what the yellow side is. Well, everything under the density curve always has an area equal to 1. So when we're looking for something when we shade it to the right, we just want to go through and subtract it from 1. And when we do that, we end up getting a proportion of 0.2578. And when we turn that into a percent, we get 25.78%, which gives us this, which makes much more sense. That is a much more reasonable number. That is something I would expect to see for something that's shaded on that side. All right, so we talked about what it looks like when we shade to the left. We talked about what it looks like when we shade to the right. Next, we're going to do something where we're shading in between two values. So we have to do a little extra work when we're doing those. So in number 7, it's saying what percentage of the runs will give the DeLorean a speed between 70 and 95 miles per hour. So I've gone ahead and drawn our graph already. We've got 70, we've got 95, we're shading in the middle. Based on that, we should be having a pretty big number when we're done. So with our table only tells us, like we've said, stuff to the left. So what we could do with our table is we could figure out this value from 95 all the way over. And then we could find this value from 70 all the way over. And if we just need that highlighted part, we could subtract those two values, and that would give us just the shaded part. So that's what we're going to do. We calculate our z-scores. For 95, we get 1.95. That's a positive z-score, which is what I would expect, because 95 is larger than the mean. For 70, we end up getting negative 1.3. Again, also what I would expect, 70 is less than the mean, so we should have a negative z-score. So when we go to table A, one tip that just makes your life a little easier is if you go ahead and do it for the larger z-score first, you can just write it and subtract the way you wrote it. You don't have to flip anything around. So if we go to table A, if we go to 1.9, and then we go across to 0.05, we're going to end up getting a proportion that is 0.9744. And then if we go to table A for the negative 1.30, we go across, we're going to end up getting 0.0968. So translating that over here, this piece is 0.0968. This whole big green piece is 0.9744. So to get just the yellow shaded area, we needed to subtract those. And so just straight old school subtracting. Use the calculator if the decimals are freaking you out, and you'll end up getting 0.8776, or 87.76%. And looking at the graph, that seems reasonable. 87%, yeah, I'll buy that for that amount of graph that's shaded. That seems like it would work. All right, last one we're going to talk about. Marty wants his last run to be in the top 15% of all the possible speeds. What speed does he need to achieve to be in the top 15%? So if we're looking for the top 15%, that means the fastest speeds. So we're shading over to the left, and we want to figure out that top 15. We don't actually know what that value is right there on the x-axis. That's what they're asking us to find. What is that speed? So the only other thing we have to watch out for before we use table A is, think about again, how do we shade on table A? table A is always shaded to the left. So if that's 15%, this is 85%, and that's what we're going to need to look for. So 85%, table A is only in proportions, so we got to convert that. So we would be looking for as close as we can get to that decimal. All right, so what we're going to do is we're going to look in the center of table A for as close as we can get to that value. And it won't be perfect, but you just want to get as close as you can. So you're going to be looking on the positive z-score side. And as I go through my table, right here seems to be the closest I can get to 0.8500. I'm at 0.8508. So what I need to do is find the z-score that goes with that. So I'm going to move along over here and realize I'm at 1.0. So that's the first part of my z-score. And then I'm going to go up to find my hundredths place. So it's at 4. So I'm at 1.04 for my z-score. Once we have the z-score, we can work backwards to calculate our value. So using our same z-score formula, it's value minus the mean over the standard deviation. Do some old school algebra to manipulate that to solve for the value, and we end up getting 88.008. Oop, put an extra 0 in there, miles per hour. Come on. All right, there we go. We'll just roll with that since this doesn't want to cooperate. If you've seen Back to the Future, you know why 88 miles per hour is important, which is why we wanted that one. So these are all the possible ways I could ask you to calculate a normal distribution. On the important ideas, I've gone through and labeled all the steps in both directions. So if you were going from a data value to the percentile or to the percent, you're going to follow the left side. There we go. All right, so the left side is if you have a data value and you're going to the percentile. The right side is if you're going from the percentile to the data value. And so these are the steps that go both directions. We will talk about this in a little more detail in class on Thursday. I hope this helps. Talk to y'all later. Bye-bye.